right, finishing up our absolute value inequality discussion. Hopefully got a chance to catch your breath. This one should be a little shorter because now we are just looking at the opposite case, which is what happens when there is an absolute value and a greater than sign. And I tend to announce it a little differently and say greater to remind me that it's an or inequality. Or you can look at my cute little Bitmoji and see greater than means or. So I'm going to start with actually the ones that look just like the ones in the last video and show how having a greater than sign changes things. Well, if I have an absolute value, if I have a distance that's bigger than 8, then that means it's either beyond positive 8 or beyond negative 8 in the negative side. So it's kind of going in opposite ways, greater than and or in opposite ways. So the way that we write this is we will write 3x minus 4 is bigger than 8. So just write the original inequality piece. Or 3x minus 4 is less than negative 8. By switching that to a less than and a negative, it's going to make it go the other direction. Because remember, the word or should make you think opposite. We should have rays that are going opposite ways. So if I'm bigger than my positive 8, that's going to go to the right. And if I'm less than my negative 8, that's going to push me to the left. I'm going to solve each of them separately. So plus 4 plus 4. It's going to be the same steps, just kind of going across here. So 3x is greater than 12, or 3x is less than negative 4. Divide by 3. Divide by 3. You get x is greater than 4, or x is less than negative 4/3. So when I put it on my number line, now I still have my negative 4/3 coming first. I still have my 4. I still have my open circles because it's not included. But now I'm going opposite ways. So my answers are everything that's bigger than 4 or less than negative 4/3. These will take a little longer to write and to kind of go through because you have those two opposite pieces. When you write your inequalities, you're going to go from negative infinity to negative 4/3 with parentheses, and you're going to join that with 4 to infinity. So if all I do on the next one is just change my inequality, so if all I do is instead of having a greater than, I have a greater than or equal to, everything else is going to be the same except for my circles are going to be closed in. And so I'm going to use brackets. So I can start it, but I don't know if I'm going to finish this one all the way because it starts to get very redundant. So I'm going to have 3x minus 4 greater than or equal to 8. Or 3x minus 4 is less than or equal to negative 8. So when I switch it to a less than or equal to, it's a negative. I'm going to solve this just like I did over here. So I know what I'm going to get at the end. I know I'm going to get x greater than or equal to 4, or x less than or equal to negative 4/3, because I already did the work. So I know on my number line, when I put my negative 4/3 and my 4, sorry, that's just 4, I'm going to now have filled in circles. Scribble a little bit. Stop. And then I'm going to go opposite ways. So when I write my interval, I'm going to start at negative infinity. But when I go to negative 4/3, I'm going to put a bracket around it. And I'm going to join that with a 4 going to infinity. Bracket around the 4 as well. So that is the difference. When you see a greater than and an absolute value, that combination creates an or inequality. Here's one that's got an extra fraction in front because I want to make sure you know how to deal with it. So if I have a fraction in front, I have a 1/2 in front, I have to multiply by the reciprocal. Again, you see this greater than sign, that greater than sign. That tells me I have to write it as an or inequality. So x plus 2 is greater than 12, or x plus 2 is less than negative 12. So it's giving you the extremes. That's what an or does. It kind of gives you those extreme opposite parts of the graph. So I'm going to subtract 2. So I have x is greater than 10, or x is less than negative 14. On my number line, always put the smaller number first. I don't care how much space you put between. These are both open circles. We're less than negative 14. We're greater than 10. So giving you that extreme look, that opposite look. And my intervals go from negative infinity to negative 14 with a parentheses, and then from 10 to infinity. Show you one more regular one, and then we'll do a quick talk summary about special situations. So again, we need to isolate the absolute value before I do anything. Before I start thinking about breaking it up, rewriting it, I need to get that absolute value by itself. So I'm going to add 3 to both sides. Divide by 5. Now I have my inequality, or my absolute value isolated. My inequality is greater, so I'm going to turn it into an OR. So 3x plus 2 is greater than 2, or 3x plus 2 is less than negative 2. So again, getting that extremes, going the opposite way. Subtract 2. So I have 3x is greater than 0. 3x is less than negative 4. Divide by 3. And yes, it is okay to get 0 as an answer. That always scares people. Divide by 3. So my endpoints here, I have negative 4/3 and I have 0, both open circles. I want everything that's smaller than negative 4/3. I want everything that's bigger than 0. So again, that look of that opposite. So my answer is negative infinity to negative 4/3 and 0 to infinity. Again, the idea that it's opposite ways when I get that OR graph. So it's either smaller than this number or bigger than this number. So special cases, we know they show up in equations. They also show up in inequalities. So I do want to mention them so that you don't do too much work with these. If you have an absolute value that you've isolated, so you'll notice there's nothing else on the left side other than this absolute value, and we are looking at a negative on this side, we have to see if what is written there makes sense. So I have the absolute value of this 3x minus 2, and I want to figure out when that absolute value is smaller than negative 5. It's not possible. If you're trying to figure out what number could I put in to get an absolute value that's smaller than negative 5, well, what I know about absolute value is it's got to be positive when I finish it. Once I put a number in and to multiply and subtract, when I take the absolute value, I am going to get something positive. It will never be less than a negative. So this one has no solution. You cannot have a less than a negative and have that be true with absolute value. Now, on the opposite side here, what if it was the same absolute value, all isolated, but we wanted to know, well, when will that be greater than or equal to a negative number, like a negative 5? Well, whatever is going to end up in here, no matter what I put in, I'm always going to end up with a positive result. So there is no chance for it not to be greater than negative 5. So this is kind of the opposite of this special case over here. This is always going to be true. So I'm going to use that all real number symbol, or you could say infinite solutions, because you can, no matter what I put in there, you're always going to be greater than or equal to a number that is negative. So I want to mention that. That's what makes these special, is what do you do if there's a negative on the opposite side of the inequality symbol? We have one of those two special cases. So that is totally the end of 1.6. You've now gone through all the different parts of absolute value equations and inequalities.